So does this thing work? Okay, cool. Hello everybody. My name is Roham Koestani. I'm a research assistant at the AI4SE lab. And today I'll be talking about evaluating ML4SE research in general, because I think that a core problem in research is that we do not evaluate our methodologies properly. So I wanted to drill some points in today. And the core claim in this lecture that I'm trying to make is that a good evaluation is an evidence-based argument that a method improves a clearly defined software engineering task under a valid experimental setup. It's a mouthful, but we'll unpack what this means and we'll come back to this core claim and see whether you agree with me or not. And of course, your projects differ in the type of tasks you're doing and the type of data you'll have and the model families that you'll be using. But I claim that there is a central risk in your evaluation. There are central risks in your evaluation, such as benchmark validity, data leakage, metrics, baselines, and etc., that your research should take into account. And by the end of this, I hope to have a reusable evaluation framework for you to be able to use inside your own research. And I'll give you a motivating example to just kick things off. Who here has heard about human eval data set? Quite a few of you. So that the human eval data set is a rather popular one. It got popularized by OpenAI during the GPT-3 era, and it's a functional correctness-based program synthesis benchmark. What does that mean? So you get a description of a function, and you're tasked with completing that function. And it's a set of 164 of these problems, and they evaluated using a passive K metric. Because it's a functional correctness benchmark, you're trying to write the solution and see whether test cases pass or fail. Good and all, but that was 2021, right? And then we fast forward to 2023. There is this paper by Liu et al., which is called Eval Plus. What they did was they took the human eval data set and they added a bunch of test cases to it to cover a bunch of edge cases, essentially. And what they saw was that these models and these data sets, they're not cover all these edge cases, because when they evaluated the exact same models they evaluated with human eval, the percentage of the pass K dropped. And then again, fast forward 2025, 2 years later, we did a very similar study, but then now we looked at the actual problem description themselves, whether they included any faults or mistakes in terms of grammar or being underspecified or whatever. And then also we looked at the canonical solutions and we identified a couple of mistakes there as well. And then we did the same evaluation by evaluating on pass at K, and we saw even a more substantial drop. Here, I note 31.22% in terms of means, but some of our models dropped by 70%. That gave us an indicator that, for example, some models were just memorizing the canonical solution and regurgitating what they had learned. So what is the main thing that I want you to take away from this sequence of papers is that a benchmark is not purely popular because it's not purely valid because it's popular. You need to have a valid reason for every single task that you're evaluating, and you need to know what your target population is, whether it's contaminated or not, and what's your protocol for evaluating whether your data is contaminated or not. And we'll work more on this. And this is the thing that we're going to be, the main point that we're going to be working on. I claim that a good claim has the following form. You have method X improves Y, so the thing that you're trying to improve, over some arbitrary baseline Z for a specific population measured by M and using uncertainty U. We'll go over all of these aspects, but I first want to take apart the elements that you have in a claim. So a claim should be testable. I can't say I'm better than person X, period. That's not a claim, right? So you can say I am better at individual X at something, right? So that is testable. You can set up a test. You can say you have a hypothesis, and you can either reject or accept that hypothesis. It has to be testable. What is your task, right? Specify your task. What are your input constraints? What are your output constraints, right? What do you define as success? I think some of you here are working on the benchmark mining project that I have. So what it is what do you define as a refactoring, right? So if you're trying to mine refactorings, what do you define as a refactoring? What is your task? And when you're looking at a population, you can't evaluate everything and anything that's out there. You have to minimize the subset that you're looking at and work on that, and so on and so forth. For data, metrics, comparisons, and inference, I'm not going to go over all these. I'll share the slides with you. You can go over them yourselves. But here I do want to distinguish between a weak formulation and a testable formulation. So our method improves code generation is not a testable claim. However, this is a very specific one. Our adaptive retrieval method improves repository level code completion over always retrieve and never retrieve is a testable claim. And I would like you to be conscious about the choices that you're making in your formulation and the eventual paper that you're going to write. So I'm here going to say something about a rule, quote unquote. You're free to follow it or not. Every research question should map to one primary metric, a baseline, a statistical unit, and a validity thread. And this should be reflected in the different sections of your paper that you're going to be writing. So you're going to provide the task that you're going to evaluate, say which metrics you're going to primarily look at, what the baseline is that you're going to be comparing with, and how you're going to test for the significance of those results. Okay, so I've talked a lot about you have to have a testable claim and you have to have a good data set or whatever. But what is a good data set? I've noted a couple of families of benchmarks, but again, just because I put them here on the slide doesn't mean you should use them, right? Do they fit your task? But let's just go over them. Function synthesis. What is that task? So again, the human eval style of task. You have a description of a function and you need to infill that function. You need to write that function. So you have the human eval types of benchmarks. You have the MBPP types of benchmarks. So they're good for short, small evaluations, and they have executable tests, so that helps. But this doesn't give you a holistic view of the capabilities of the model. And then you go a step further. Rather than having an actual method level completion or a class level completion, you want to do repository level completion, right? Or repository level generation. And then you have the repo bench style of benchmarks. You have the cross-code eval style of benchmarks. And you'll come across these in your papers because these are canonical papers. You have issue repair, which is given a specific issue on GitHub or your repository. You want to give it to an agent to fix that bug so that the tests eventually pass. You want to have refactoring that I've been coming back to today, is that you have a specific state that you're currently in with your code base. You want to make some changes in your code, but you want to still preserve the same semantics of your program. Mining studies are a whole other beast in themselves, and they have other ways to benchmark whether their quality is correct, good or not. And then you have the user-facing tools that you're developing a research-facing tool, and you want to evaluate, okay, does this work or not? And then in those cases, you primarily want to go towards evaluating the users that you want to develop for. So there is a checklist that I usually use for myself, and I think about it. I distinguish between two things when I'm choosing a benchmark. So I distinguish between task quality and benchmark quality. So what is task quality? I want to know whether the tasks that I have are precise, because LLMs rely on this precision to be able to give you a correct answer. So I would like to know whether the tasks that I have contain enough information for my LLMs to go off of. And if they have enough information to go off of, do they provide the correct canonical solution? Because eventually, when I do have a solution from this model, I want to evaluate whether the model produced the correct answer or not. So I want to be able to rely on the answer that it's giving. Does it have enough tests? And if we're talking about this, are the edge cases handled in those test cases that are provided? These are all stuff that we want to think about. But then when we look at the grand scheme of things and we look at a benchmark level, is the provenance of the documents collected in the benchmark noted? So do we know where these repositories are? Can we go find them ourselves, or are they human-made tasks? Did humans actually write them? Do we know who created them? Are they being maintained? Is there a leaderboard? Do I know how my model compares? And finally, is the creation method auditable? Was it published in a peer-reviewed journal, for example, or a peer-reviewed conference? And can I talk to the authors that created that benchmark? So this is all about benchmarks, but then when you're stepping into the evaluation using the benchmark that you chose, there are a couple of leakage and contamination concerns that can arise. What is leakage? So who here knows what leakage is? Okay, cool. So leakage is when you have data that you've trained on be sort of unwillingly included also in the data that you're evaluating on. And that is unintentional. Why? Because when you train on that data, your weights and your distributions are fitted to that data. And when you evaluate your model on that exact same data, your model's results get inflated because it's already seen that data and you're not really evaluating whether the model generalizes or not. You're seeing whether it works well on in-distribution data, so to say. And there are a couple different failure modes that we can have here. So exact duplicates, so the exact same file is in that in your evaluation data, and this is bad because if you have this, your results are completely invalid. New duplicates are kind of a gray space there because they might be there because you didn't control for forks of a repository, which include the same implementation. There are clones, there are templates, but there's also the case that people copy code without proper attribution in their repositories, and this is a case that's a lot of times overlooked. So you want to also keep that into account. There's repository leakage, so the entire repository is just in the test, and there's temporal leakage because your models are trained up to a certain point in time. And you would preferably want to train on data that comes afterwards just to make sure that the model was not trained on data. Even if you're evaluating on repositories that were in the training data, presumably, you would not want to include data that was included in the training data. So that's what we do. So we take the cutoff point of the model, we let them train on whatever they want, and we look at what we have now after the cutoff date, and we evaluate on that. And that gives us a better view of what's happening. Benchmark contamination is something that's very frequent. So if the benchmark is out there for a long time, we cannot rely on it. It's probably been trained on. So we need new benchmarks and we need iterative benchmarks. And prompt and date test leakage are common things. So when you're evaluating, your prompts would include, for example, the answer. And I won't go into the splitting strategies. This is something that you can study on your own. But metric validity is a very important one. I've seen so many times papers come around and they're like, we improved this very specific thing, and they're not evaluating for that. They're like, we improved the test passing, and they're not even doing functional correctness testing. So I want to drill this in. So when you're evaluating code generation, the metrics that you have to do are pass at something. So pass at 1, pass at 5, pass at 10, and pass at k in general. You want to check whether the code that you've generated compiles, or well, at least parses. So compiling is a whole different thing. Whether it parses and whether it compiles, and whether a holdout test set passes. These are basic things that you want to evaluate. When you're looking at repair, You want to see whether primarily an issue is resolved or not. So you want to see whether the previous state goes to the post state that you're looking for. And how do you compare this? Here you can use proxy metrics, and I'll get into what those are. But if you have tests at your disposal, you should probably be running those tests. So running the regression tests, running the fail to pass tests in your benchmark, such as SweBench. And also, cost is a problem nowadays because you're using a bunch of tokens to produce these repairs or patches. So you have to control for that. So you want to know how much did it cost to actually re- repair this bug. When you're doing refactoring, the most important thing again is not that the model can do it. It's that the semantics of the application remain the same. So when you give it the same output, you get the same output back. So what is the correspondence between the reference solution and the solution that your model provided? And here you can look at various different metrics that I've listed here. In RAG, who did the information retrieval last quarter? Yeah, so these will be very familiar metrics to you. So when you're doing RAG, for example, for code completion, you have a bunch of metrics such as recall at K, mean reciprocal rank, and DCG for the retrieval phase. But the additional part that gets added in the AI4SE sense is that you use that retrieve sequence to actually achieve something. So you retrieve a sequence, you pass it to the model, and you ask it, okay, generate me a solution based on these retrieve tasks. So you usually have a two-step pipeline, retrieval and then generation. You evaluate the retrieval separately, and then you have the generation evaluation set separately, and then you go back into the code generation era. Mining studies, again, a whole different style of study that you're doing. Did you uh, keep into account what your distribution that you're sampling from? How much of a confidence interval does this sampling give you? All that sort of stuff. And then finally, user studies. When you're evaluating this, how much time did it take users to complete your task? Did you control for carryovers from experiment to experiment? How many attempts were there? Was the final code passing or no? These are valid concerns to have when you're looking at user studies. And here I want to take a second to acknowledge a matrix called the code blue. The NLP equivalent to this is blue, but it adds essentially syntax and data flow constraints to the blue metric that is commonly used in NLP, and it's seen as a very good, well, it was seen as a very good indicator of performance when you're looking at how well a model did in correspondence with a golden solution. And these are the blue style metrics are not a one-off. They're called proxy metrics in evaluation, and we have a whole bunch of them. So the proxy metrics that we have that and I'm referring to here are, for example, exact match, which is a very strict one. But you also have edit distance, for example. You have blue and all those blue style like rouge, rouge L, all those metrics. And you also have static quality metrics that are task independent, and we can go over them if you want. But there's also this new notion of LLM as a judge nowadays, where you have a reference solution and you have the generated solution, and you ask a maybe larger model to evaluate how the generating model did. So you have a predefined rubric, and you ask it to grade the generation. And uh, I would actually highly recommend you to read this paper by Zheng et al., where they looked at how you can use LLM as a judge very, very effectively. Okay, so we've been talking about benchmarks, we've been talking about evaluation metrics, but now I want to talk about baseline. So when you're choosing your approach and you're evaluating how well or not well your approach does, you want to look at baseline. So you have various different types of baselines that you can look at. So you have naive baselines, so I don't know, you're evaluating a agentic approach, and you choose the most standard baseline of just a symbol model, just a bare bone LLM compared to an agent. You say my agent does better. So there are these classical baselines that you can evaluate against. So if you're doing retrieval, for example, BM25 is always the baseline that you use in this classical setting that you're looking at. In terms of models, you usually can include, if you're evaluating on very much closed source models like the GPT style models or Claude models, you can always have a model baseline that is an open source model, for example, or the converse. If you're evaluating on a closed source model, the safe baseline is always to compare to GPT style models, and then you'll pretty much be fine. And then there are workflow-based blinds that are dependent on the task that you're actually trying to evaluate. So if you're introducing this new tool, you include that tool or don't include that tool, and those are your two the two configurations that you're working at. Ablations. I do not see enough ablations in AI4SE evaluation, actually. So what does an ablation study mean? So you control the different components of your system and see what their specific influence is on the outcomes of your study. So if you have a multi-stage pipeline, for example, you enable or disable that specific stage in your pipeline and see how much of an impact it actually has on the performance of the whole. So let's say if you're doing a complete generation pipeline, you evaluate it with and without retrieval, with and without adaptive retrieval, without having feedbacks from tests, and so on. And you have a control for confounders in terms of the repository, the size, reviewer effects, all that sort of stuff, and you can carry out a very much a good ablation study. But you need to be aware that this is something that you can do. And also, report how you report is very much important in ablation studies. You can't claim causation by not testing it. So when you do ablation studies, you gain support to be able to do causal inferences in your text. Since we're kind of getting to the final parts of this claim that I initially stated, but then we have this uncertainty ranges that we have to deal with. Just because we have a result in terms of means doesn't mean that those results are valid. So you have to do statistical tests depending on what your case is. So if you're comparing two systems on the same task, so you have binary outcomes, you can have a bunch of tests. And I'm not going to go over every single one of these tasks that I've included here, or tests that I've included here, but I would really encourage you to go over them and go to your TA or even me to discuss what would be the best test that you can apply. Okay, so we talked about benchmarks, we talked about evaluation, we talked about statistical testing, but then robustness. So you're going to be eventually writing this paper that we're going to grade you on. And I personally am going to be looking at how robust is your experimental setup. How have you phrased your prompts? Have you been explicit about indicating how you use those prompts? How did you order those contexts that you provided to the model? Why did you use a specific model family? These are all things that a reviewer is going to be looking at. And nowadays, when we're dealing with these different types of models, there are gazillions of models on Hugging Face. I want to know very specific things about your experimental setup. I want to know what model did you use and what version of it did you use, because models get updates rather frequently. What was the prompt that you used, and did you log those interactions in terms of the prompts? What tools and architectures did you use? what decoding parameters did you use? Did you use a high temperature or a low temperature? Because that definitely influences the quality of the results that you get. How frequently did you repeat those experiments? And finally, how much the cost and the latency was for producing these results. And there's this very nice paper by Baltus et al. That I would really encourage you to read up on in terms of how you should report in the era of LLMs. And just for you, I've included like the archetypes of your projects that you have in this course, and I would look at this because I included some like key points that you can have in mind when working on these projects. And I wanted to do this, but who has interest in doing something like this right now? So uh, we would go into groups, choose one of the projects that you're working on, and decide what metrics, baselines, and all that sort of stuff could be relevant to your project. By a show of hands, does anybody have an interest in this? Okay, so we'll safely skip this one. Main takeaways from today's talk. So main thing, align your claims, task, data, matrix, and baseline. Those are the 5 things that I want you to please take away from this, because this is what you're going to be evaluated on at the end of the day in your report. Choose your benchmarks for representativeness and not popularity, just because the latest OpenAI Anthropic paper used that specific benchmark does not mean you should use that benchmark. So do not trust leakage controls and reports that are present in benchmarks. Control for them yourselves. Justify your metric choices and why you think a specific proxy method um, works for you. And if it does not work for you, why is that a limitation? Use fair baseline control for different components in your system by using appellations, and report uncertainty, robustness, and reproducibility in your results. I have a list of readings based on the specific topics, so metric validity, statistical inference, and so forth. And yeah, that was pretty much it. Yeah, thank you.